I will get started. Uh, Thank you all for being here. My name is Aparna. I am coming to you right now from Boston, Massachusetts, where I work as a lecturer in biomedical informatics at Harvard Medical School. And today I'm really excited to be able to share with you some of the work I've been doing on teaching LLM literacy as a way of improving AI-aided data analysis in a bioinformatics course. So here's a little bit of an overview of what I'm going to talk about today, and I'll kick it off with some motivation. Luckily, the previous talk has already set some of this up, but we know, especially if we're educators working in the classroom, that students are using AI tools in really almost all aspects of academic work. If you'd like to see some data to support this, what this data is actually a global survey that was carried out last year of undergraduate and graduate students, where 86% of students claim to use AI in some capacity in their academic work. And if you want to know what they're using it for, there's some other data collected the previous year in 2023 that included some high schoolers as well. And it shows that really students are using AI for many of the same things that we might be using it for. So they might be using it as a way to get information, to brainstorm. But I think for me, the most interesting thing here as someone who is an educator and specifically someone who teaches coding was seeing how many students are really using this to help with schoolwork and also to help them write code. Now, obviously 2023, very different from 2025, but even just drawing on my own experience, as I started thinking about what students could be using these tools for in courses like mine, I realized there's just not a lot of literature on AI use in sort of bioinformatics courses specifically, but there's a lot of literature on using these tools as part of data science and computer science courses. And a lot of that information can be transferred over to how we think about our bioinformatics courses. And so from the data science, computer science literature, we can see that there's a lot of evidence that AI tools can really support students as they write and debug code, as they explain code, translating code between programming languages, brainstorming solutions to problems, or even creating artificial data sets or test cases as they code. And so not only are these really important skills for learning in the classroom, but we know that they're also becoming important workplace skills. And so thinking about how we make decisions around this, if our goal is really to empower students with skills that will help them enter the workforce, it's really important for us to think about how we teach literacy around these AI tools. We also know that effective use of these tools matters. And a lot of literature exists here largely from the data science and computer science education fields, showing that if these tools are used effectively, they can actually promote learning, they can promote self-efficacy, and even build students' confidence. On the other hand, if they're used ineffectively, they can actually hinder learning, they can sort of prevent students from actually problem solving, promote over-reliance, and actually create inequities between students. And so this poses a really interesting challenge. These tools have the potential to help bioinformatics learners, but only if they know how to use them effectively. So that's where my project comes in. And today I'll specifically talk about one particular goal, which is to develop an LLM or large language model literacy curriculum to teach students best practices for using AI tools for biomedical data analysis. And the data I'll show you today specifically comes from the work on teaching them how to use these tools for coding. As I started this project, I kind of had two hypotheses of how this could help learners. One was that it could help improve their AI-assisted coding practices. And the second was that it could also improve their confidence as they complete these coding tasks. So with that goal in mind, I'm going to tell you a little bit about how I actually designed the study and implemented it. Overall, the study had 3 phases. The first step was to actually design this curriculum, this generative AI literacy curriculum. I started this project back in fall, winter of 2023, and at that time, there wasn't a lot of concrete curriculum available on the internet. Now there's definitely more, but it's still not exactly what I was looking for at the time, which was something that was modular, something that was kind of prepackaged and more tailored to bioinformatics, or at least to biomedical contexts. So then once I developed that curriculum, the second step was to actually implement it within the context of a bioinformatics course, and then finally to evaluate how it actually impacted students' learning and coding. So I'll start with step 1. The curriculum I ended up designing is heavily informed by evidence in the literature, and specifically I drew from bioinformatics literature, computer science, data science, but also pedagogy literature. I designed 3 modules so far. The first module was a background module on LLM basics, and the goal here was to get everyone on the same page in the class. So understanding how LLMs work, common applications, and some of the ethical questions surrounding their use. The second module was on using LLMs to debug code. In this case, this was about debugging best practices, so things like writing pseudocode or unit testing, but also some LLM skills like prompt engineering, and bringing in that pedagogical learning element of good strategies to use LLMs to support learning. So things like encouraging students to iterate with the LLM or asking the LLM to take on an instructor persona. The third module was on using LLMs for statistical design. And this module was definitely a little bit different because there's not as much literature on how to do this in the best way. So instead, I chose to use this content as an opportunity to focus on critical thinking and reasoning skills. So encouraging students to explore how they would translate a statistical scenario or a simulation into a prompt, how they might critically evaluate an LLM suggestion, and we worked as a class to actually co-create guidelines for best practices. So today in the data I'm going to show you in a little bit, it's all going to come from the first 2 modules, so specifically on the LLM basics and also using LLMs to debug code. So then the second step was to actually implement this curriculum in a way that students could engage with it. I chose to do this using Articulate Rise, which is a course authoring software. It had a lot of features that were quite helpful for what I wanted to do. The big advantage is the very easy to use design interface. All of the kind of features that you see in this video over here were custom blocks that were pre-designed. I didn't have to write any code to make this possible. And in my institution, we use Canvas, and this was able to integrate right into Canvas and allow me to grade and record sort of student outcomes through Canvas. Definitely there are some downsides here as well. The available blocks on Articulate Rise are quite limiting, especially for assessment. So all assessment ended up having to happen in Canvas separately. Similarly, I couldn't embed an LLM into Articulate Rise, at least at the point when I was building this. And so any LLM interactions also had to happen outside of this course environment. And the number one limitation is the cost. This is a paid service. It required an instructor subscription. So it's definitely not the best tool for everyone. But by using this tool, I was able to actually put together a pretty diverse set of materials for the students to work through. There were readings and videos mixed with reflections. These reflections would often sort of go back to Canvas, where they could actually answer some questions, respond to some prompts. And then I also provide the students with some cheat sheets that look like what you see over here on the right. These were essentially meant to be materials they could take away and use as a reference throughout the course, kind of inspired a little bit by some of the Posit, Tidyverse R cheat sheets. There's a lot of actual literature that suggests that having these kinds of takeaway materials are quite helpful for students. So from there, I actually wanted to take all of this content, put it into my class, and evaluate how it was impacting students' learning. To do this, I incorporated the modules into a fall 2024 biomedical data analysis course that I teach for graduate students. In this course, there are some prerequisites. You have to have basic R programming skills in advance. And so we ended up having 37 students substantial prior quantitative experiences. To give you a sense of this, here's a bar graph showing the courses each of the students came from. And so you can see it's biomedical informatics, health data science. And this is really important to remember that these are not beginners. These are people with quite a bit of coding experience already, which is good context for the data you're going to see later. The course is 14 weeks in total, but students completed most of this curriculum pretty early on in the course. In week 2, I had them complete the background module. They did a pre-test, then the debugging module, and then later on a post-test. And on the pre-test, the post-test, and any exercises throughout the modules, they were specifically asked to use generative AI tools. I didn't specify which ones exactly, but then from their interactions and the data that they generated through these modules, we were able to actually get a lot of data on how the students were using these tools. Specifically, we had pre and post tests with survey questions about their experience with debugging or using AI tools. We had some coding tasks where they submitted their responses. And for each coding task, they also submitted a full transcript of their interactions with whatever generative AI tool they used. And in this case, it could be a screenshot, it could be a link to the session. And then we took all these data and anonymized them using random IDs so that we could do a paired pre and post comparison. So I'm going to show you some of the data now, organized around some key questions that I had in mind as I was looking through this. The first question was, how are students using generative AI tools for coding tasks? And this is even prior to doing this curriculum. When I asked students how often they use LLMs for writing and debugging code, most of them, so more than 50%, reported using LLMs as coding aids at least some of the time. And this aligned with essentially what I had expected from working with the students. I also asked them about previous training in debugging, like had they previously learned best practices to debug code, and most of them had, at least in an informal setting, maybe even in a formal classroom or workshop setting, learned some sort of best practices for debugging. And this makes sense because a majority of these students have prior undergraduate training in a computational field. But then when I modified the question to ask whether they had been trained in best practices for using LLMs to help debug code, almost no one had. There were a few who had some informal experience, which we defined as maybe a YouTube video, a peer, some sort of online resource, but no one had been formally trained in this. And so this really underscores the gap that we were trying to fill. We know from the previous data that students are using LLM-based tools for their coding, but they haven't actually been trained in how to do this effectively. And so then I want to actually quantify that. So how effective are the debugging practices that students were using before this curriculum, and how does it change after the curriculum? This was a little bit of a tricky task because I had to take a step back and actually ask, what is effective use? And I decided to break it into two steps. First, there's effective use for bioinformatics outcomes. Are they getting the correct code, the correct statistical test? Are they doing it efficiently? But also, are they using it effectively for learning outcomes, things like critical thinking, confidence, decision-making, and building transferable skills? So to be able to evaluate both of these, I put together a coding scheme to actually evaluate the quality of their AI-assisted debugging. The data I used for this were those LLM interaction transcripts that they provided, along with a self-reported description of their debugging process to capture anything that might not have been in their LLM transcript. From this, I coded each individual's transcripts and self-report into a few categories based on practices I saw that were either positive, neutral, or negative. I'll talk about the specifics of these particular practices a little bit later when I show the data. I do want to just point out that all of these practices came from previously published literature on debugging and AI-assisted learning. So the first set of practices I want to focus on are the positive practices. So these are things that prior literature has suggested are positive AI-assisted debugging practices. We can see that many of them significantly increased after the training. So in each of these bars, the bar on the left in gray is the pretest. How often was this practice used on the pretest? The red bar is how often was it used on the post-test. So we had significantly more testing of code before using the LLM, outlining a solution before using the LLM, isolating the error, and prompting an LLM for an explanation of its solution. And so these are good things that we want to see our students doing. I also looked at what context students were providing in their prompts, and I could see that there was significantly more context, especially more students describing the structure of the data set they were analyzing, and even simple things like the names of the variables or the purpose of the task. Some other practices changed. We saw somewhat fewer students just copying and pasting a question or a task verbatim into the LLM prompt, which is a negative practice. We also saw somewhat fewer students iterating with the LLM. So by iterating, I meant going back and forth sort of 2 or more times with the LLM to get to the right answer. And I'll return to this piece of information a little bit because I wasn't quite sure how to interpret it at first. Ultimately, the thing I was most interested in was how successful students are at solving these coding problems before and after they did this curriculum. These are very, very talented students, and so they kind of often arrived at the correct answer with or without this training. But more interestingly, what I found was that they could arrive at the correct answer with fewer LLM iterations after completing this curriculum. So before on the pretest, it could take up to 6 iterations to get to a correct answer. And on the post-test, they could get there often in just one. And what I ended up seeing is that it was because they were writing a better prompt up front and thus getting a better answer with fewer incorrect intermediate responses from the LLM. Finally, I wanted to know how they were actually changing in terms of their confidence about debugging. And so I surveyed them on their confidence in debugging code in general on the pre and post test and saw an increase in confidence. I also asked about their confidence in debugging with the help of LLM-based tools, and that confidence also increased between the pre and post test. And so we can see that students are becoming more confident with the kinds of tasks that we're going to expect them to do in the class, and honestly beyond the class as well. So with that, I'll wrap up with a few final conclusions. As a reminder, the problem I was tackling here was that bioinformatics students are using AI tools for coding, but haven't been trained on best practices. The solution I'm proposing here is that I developed an LLM literacy curriculum that's focused on biomedical coding applications. And when I actually implemented this in my classroom, I found that students were more likely to use effective debugging practices. They were able to solve tasks with fewer LLM iterations, and they were more confident about their debugging skills. There's a lot of next steps here. I'm still revising the curriculum based on student feedback. I'll be re-implementing it in this fall's course and building new modules. I also have a ton of data on the statistics module, which I didn't get to show here because of time constraints, but happy to talk to anyone about that if they're interested. And with that, I will wrap up. I'd like to thank everyone who helped me with this, including my funding. I hope to make this curriculum publicly available pretty soon, but feel free to email me if you have any questions before then. I'm happy to take some questions or hear some feedback now. Thank you.
So thank you very much, Aparna. I think we've got time for a couple of questions.
Hi, this is really cool work. I have one little question, and then a bigger question. So the first one is, it looked like after, even still, only like 30% of students were checking the output of the code to make sure it works. Is that because the response rate on the survey was low, or is that just like an actual result?
Yeah, so the percentages are out of respondents for the survey. So yeah, that would be the actual percentage. And I think that some of that might come from the difference in how well students self-reported that, because testing the code was something they had to self-report. And so there's definitely a little bit of inaccuracy or uncertainty in how accurately people reported that themselves. They might have done it and just not thought to mention it.
Question is, did you change this looked like it was at the very beginning of the course. Did you change the other assignments in the course after from previous semesters to sort of incorporate the use of LLMs as an encouraged element rather than a discouraged?
Yeah, so definitely we'd already been changing our policy for the class as a whole to not prohibit the use, and in fact to give students some guidelines on how they can accurately sort of check their work and also report that they used LLMs. So yes, that was something that this content actually was a really nice launching off point for. So it allowed them to kind of see that we appreciated them using these tools as long as they were using them effectively. And then students actually did, throughout their assignments, start to note when they were using these tools and how they used them.
One more quick question.
Yeah, Aparna, I was just wondering if you were teaching this to a different audience, maybe those who were brand new to coding, what you would do differently, and would you assess them differently maybe?
Yes, so I think probably the main thing I would change for a beginner's audience here would be the background content, which assumed some amount of computer science exposure before, and probably the complexity of the tasks. But I think a lot of the actual lesson content was pretty conceptual, and actually wouldn't need to change too much for an audience that didn't have that background. But definitely, and the nice thing is because all of the assessments and the practice questions that were built in are kind of modular. They can be slotted out, they can be changed, they can be randomized for different students. There's room to include some flexibility for level of expertise as well.
So if we can thank Aparna again, thank you very much for joining us today.